And Tech Tank. So how many of you, obviously you guys are probably aware of our meetup group, because that's probably most of you found us. How many of you are part of like our Slack community or any of the other communities that we run? Awesome, about 2/3 of you. So Tech Tank, it's not a like organization with a lot of money or resource behind it. It's really just a bunch of people that came together to kind of create a community of engineers or anyone else interested in tech in an inclusive way to sort of support us all kind of growing and fostering and learning together. There's 6 of us that kind of are the administrators. That's the 6 people up there. So even though you see me, there's a lot of the people that do a lot of work to be able to do events like this. Including actually, I should mention, we have additional volunteers who are not up there as well, and they also help in various ways to help us get these things up and running. But if you are not part of the meetup, there's a QR code. You can come join us on meetup if you maybe heard about us through a friend or directly through Microsoft Reactor. You can also follow us on LinkedIn if you want to, because we have a lot of content and activity and other virtual talks that are not even part of this, and we post all of those up there for people to find. This is kind of the big one. If you aren't part of our Slack community, it's a pretty active Slack community. So I talked to a couple people who are really interested in some of the stuff that we would be doing. This is the one I'd recommend that you join, and I'd imagine that maybe only half of you are actually part of it. But this will all be up later as well if you want to get these URLs. Just raise your hands. Who's the first timer to any one of like our events? Okay. You know, what's interesting is, and applause to you for coming, but that number or that percentage has gone down. We're getting more and more people coming back, so that's really cool to see that we have kind of that true community fostering. New devs, raise your hand if you would consider yourself as someone who's either trying to break into the industry or maybe it's your first job in the industry, so you're still consider yourself as a new developer. Raise your hands high, be proud. Yeah, awesome, welcome. So, well, one of the things we always know is coming out to either events like this, or things can be intimidating. I'm also a self-taught developer, not 10 years ago, but like it was communities like this that helped me kind of feel comfortable. And so again, applaud yourselves real quick for having the guts to come out, show up, and consider yourself developers rather than just being shy and not wanting to show up. All right, who's hiring? This tends to be a small number because it's usually companies that are sponsoring. Anyone want to sort of raise their hand and ask if their company is hiring and let people know? I'm not there. All right, who's looking for a job? Let's raise your hand. All right, good number. That tends to overlap a little bit with the new developers, because it's sort of where you are trying to break into the industry. All right. So another thing, we source all of our talks from the community. So if you're interested in being a speaker up here, it's not something that we kind of use a guard, and we've got plenty of speakers that come from even the audience who will volunteer. So if you go to that QR code, you can essentially fill out a quick form, and allows us to find you and talk with you and schedule you for an upcoming month. Also hosting. So Microsoft is hosting this month, and we appreciate that. But every month we need a company to do something like this and sponsor. So you'll see if you've been part of our community for a while that we tend to have different venues for every month. If you know that your company or maybe a friend's company would want to do something like this, again, QR code, you can always go and fill out the form and help us get in contact with you and set up a way to sponsor that. If you want to kind of be the POC, even better. All right, before we get to our sponsor slides, this is an important one. So we have a hard stop in this room at 8 p.m. They're turning the room over for another, I think, event tomorrow, is that right? Which means you will be forcibly removed. That's not good. Well, so we're going to try to wrap up all the presentation stuff by like 7:10, 7:15. But when we start hitting that 8 o'clock mark, try to be respectful and make sure that even if you have continuing conversations, find a place to go do downstairs in the lobby. We also will be kind of announcing maybe a bar nearby that we want to all kind of congregate on, so you can go and continue your conversations there as a community. And we'll let you know what that bar is to be closer to that time. So final QR code. If you love what we do, help us by donating. No one gets paid to this, we all have day jobs. But if you feel so inclined, you can donate by Interac or by card. And join us next month. So we haven't actually posted the QR codes blurred up because we haven't actually like made the event fully live, right? So we just did. But we did. You're right. My bad, Chris. We should have put that QR code up there, which we can. But if you go to the meetup group that you guys all kind of saw initially, we just put up the March 26th event. That's going to be the Women in Tech event at the Cohere office. And that was actually unique because that was a panel. So it'll be a lot of fun. All right. So, Alexia, if you want to go up and say a few words.
Okay, sorry about that. Hi, everyone. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I see a lot of familiar faces in the room, which is absolutely awesome. Welcome back. And I see a lot of new faces also, so we're very, very excited to have you here at the Reactor for the first time. If this is your first time, it's actually a full house tonight, so very excited. I wanted to give you some more context about the Reactor and how we work and what we do, as well as how we collaborate with community groups like TechTech. So the Reactor is a community-focused program from Microsoft that operates in 12 physical locations around the globe. So we're kind of all over, but you're obviously in Toronto. And what we do is that we organize these kind of events. We organize in-person, community-focused events. It's always accessible for all and free to attend. And our event range from networking opportunities, panels, presentation, workshops. So we have a whole lot of exciting in-person events in this office. We also host a lot of virtual sessions and workshops that you can benefit from, especially as a developer and folks who are learning more about AI technology is what we're currently focusing on to respond to the high demand on AI technology. So we have experts from Microsoft as well as our partners coming in online to host lots of sessions. And all of our sessions are recorded, so always available on demand. If there was anything in particular that you wanted to learn more about, we most definitely have a session for you on our website. But in terms of the events that we do in person, we collaborate with, as I said, external community groups to bring great events and great communities like you folks in the space. We have lots of exciting upcoming events, again, ranging in topic, and today will be a presentation. We have a panel next week, lots of networking opportunities. I saw a lot of you raising your hand in terms of looking for a job, so you're definitely in the right space. Coming out in person, meeting new people, networking is definitely the thing to do, so kudos for you on that. And if you're interested in learning more about the events that we're having coming up, feel free to scan this QR code, which I will bring back again in a few seconds. But before we move any forward with this event, I would like to take a moment to review our code of conduct. Please have a moment to read it. Microsoft Reactor seeks to provide a respectful environment for our audience, our presenters, our organizers. So yeah, please be kind to one another and we'll have a great event. And this is where you can find us to stay up to date with the events that we're having. As I said, we have 12 physical locations, so all of our content is coming and cross-promoted from different locations around the world. So there's always something that's streaming at any part of the day. So feel free to check out our social media to know what's going on. But if you scan again this QR code, you'll have access to all of our social media channel as well as our upcoming events in Toronto particularly that you will be that you could attend. And if you have any questions, I will be around today. And if you want to ever collaborate or also speak at one of our events, feel free to send an email at reactortoronto@microsoft.com. Yeah, thank you all so much. And we'll bring in our speaker here for tonight, which I can't see right now. Oh, there you go. Hi.
Is that better? Okay, great. So, and I even injected humor into my presentation. Off to a great start. Okay, hello everyone. I'm excited to have you join me. I'm Myles Harrison, and I'm excited to deliver this presentation that I am calling Generative AI for Developers. If you want to post any photos or anything, or tag anything, I am building a training program and consulting called NLP from scratch. I don't really use a lot of social media, mainly LinkedIn, but I'm also on the platforms that are listed there with those icons if you want to check out NLP from scratch at any time. Okay, let's get into it. So we're going to talk today about building. And so for the agenda, we'll have a brief introduction. Then we'll talk about materials for building. We'll talk about tools for building. We'll talk about building and building. And then finally, I'll leave you with some resources to take you further on your journey in generative AI. Okay, so quickly, who am I? As I said, I'm Myles Harrison. I'm not a developer. I am a data scientist. Previously, I was a career consultant. I worked in the agency world. I also worked at Big 5 consulting firms and independently, as I'm doing now. I also was an educator. I led the global data science team at the bootcamp down the street there over at Spadina and King. And then this past summer, I also taught a conversational AI course in a traditional education institution. I am also a meetup junkie, so I go to lots of meetups. It's great to meet people, learn new things, be part of the tech community in Toronto and elsewhere. And now I'm here presenting at this meetup. And I'm just going to keep walking back and forth here because I don't have a clicker. All right, so already had the intros, but I wanted to say personally just a huge thank you to TechTO for giving me the opportunity to speak here, and also a huge thank you to Microsoft and the Reactor space for hosting us here. I assume if you're here, you've seen these different organizations, but if you haven't, those are the URLs for these, so please check out those and support these organizations that are doing great things for the tech community here in Toronto. Okay, so I am not a developer, but I will recite the developer credo first, which is let us build. There's all these new amazing tools and technologies coming out around AI, generative AI. What can we build? Let us actually build something amazing, interesting, and hopefully actually useful with these amazing new tools we have at our disposal. So that is the goal for what we are talking about today. And in order to build, you need materials, raw materials, but in this case, the raw materials in this presentation are also going to be the background materials. So there's just going to be a brief introduction to machine learning and AI itself a little bit at a high level before we get into some of the tools and techniques. So some people may be familiar with this figure. I did not create this, but in traditional classical programming, if this, then that, you have data, you write rules, and then you get answers out of your application or a behavior. This is different than machine learning, where you put data into machine learning with the answers, and then you use statistical algorithms or machine learning algorithms to learn rules or make behaviors that you want based on the data and the answers. All right, now it's a little bit of a different paradigm because we actually had traditional machine learning. So in traditional machine learning, you could have like a picture of a hot dog, then you feed it into your hot dog, not hot dog model, and it would give you a prediction of the class and a probability of that class of the photo, right? That's traditional machine learning. Now, okay, it's Gen AI, it's the new hotness. We have large language models or LLMs. So now the paradigm's a bit different. You have a prompt, you say, write me a poem about applesauce, you put it in the LLM, and then the LLM writes you this beautiful poem, right? This thing down here is actually technically the same type of machine learning as above, and your task here is actually to predict the next token, and it's treating the next token prediction as a multi-class classification problem where the number of classes is a very, very large number of all possible words. So technically, this sort of new paradigm is still doing traditional machine learning, but just there's so much complexity there that it feels a bit different. So let's talk about these things in that way going forward. Okay, in terms of how these models are trained, the training for large language models and generative AI models is definitely different than traditional machine learning. On the left, we have what is called pre-training. This is something that only large organizations, we're talking about FANG companies or OpenAI companies with very, very large budgets and massive scale of infrastructure can afford to do, where they're showing the models very, very large data sets of text. We're talking about like double-digit percentages of the internet here. And then after that, you have the application of reinforcement learning. So training a reward model to sort of shape the behaviors of the pre-trained model, the pre-trained LLM, this was something that OpenAI came up with, which was a really key innovation, and really was sort of the secret sauce that made ChatGPT just so groundbreaking. And you can see this with the shaping of behaviors of text models we have now, like ChatGPT gives you these responses that are always a certain way with bulleted lists and things like that. And that's a result of shaping the behavior with the reward modeling piece. And then finally, once you have an LLM that's all trained and everything, you can do what is called fine-tuning, where you show it more data, typically much, much smaller data sets, and then this continues to shape the behavior. Or you can even do things like adapt a pre-trained model to a different task that uses language as well, and it may perform very well in this new task. So most people definitely cannot do pre-training, probably not doing RLHF stuff, reinforcement learning, unless they're very technical. But many people can do fine-tuning. You can do that on your laptop or in Google Colab or wherever. OK, what else? So in case you're not familiar with large language models, the vast majority of large language models are based on what is called the transformer architecture, so much so that people use these terms almost interchangeably sometimes. The transformer architecture was introduced by Google Brain in a paper in 2017 called Attention is All You Need. And the vast majority of all large language models today are based on different variations of the transformer architecture. This is what the transformer architecture looks like in a diagram. This is a diagram, a high-level diagram of a deep neural network that is a transformer architecture. These things you can actually stack those different blocks many, many times. And then on the left, you have at a high level what is called the encoder. And on the right, you have what is called the decoder. And then if you have both those pieces to a transformer model, you have what is called an encoder-decoder model. The vast majority of new LLMs that are coming out today are decoder-only models. And this is because of the precedent set by ChatGPT and the GPT series of models, because GPT is a decoder-only model. Okay? But what does that actually mean? Well, I don't have time or the wherewithal to get into the mathematics. But at a high level, waving my hands, the encoder, you give it lots of text and you teach it meaning about the world. It sort of shapes the worldview of the model, and it learns things about how different terms and language relate to each other and concepts that are related and things like this. When you put text into the encoder, you get out a numeric representation of language, and this is what people refer to as a text embedding or a word embedding. Okay, so the encoder is sort of what the model knows about the world, whereas the decoder is sort of training the model how to actually speak and how it talks. So if you change the training with the decoder, it's sort of how the different outputs come out of the text model to actually, form language. All right. So that's my high-level, hand-wavy description of those things. A piece of terminology we're going to rely on here is this idea of foundation models. This was a term that was introduced by the Center for Research on Foundation Models at Stanford in 2021. And basically, they're saying that these new AI models are so big and they're so different from the machine learning we've done in the past that the term model is not enough. And they came up with this term foundation model. Because not only are these models very, very important in terms of what they can do, but they also even have societal impacts. There's no denying that ChatGPT had a societal impact really on everything. So this term foundation model is now how you refer to these different series of models. Some foundation models to know. Obviously, this is not an exhaustive list. Everybody, including your grandmother, even if she's dead, knows what GPT is. GPT-4, obviously the state of the art there. And those are a decoder model. GPT-4 is a mixture of experts model with 1.76 trillion parameters. From Meta, we have the incredibly popular Llama 2 series of models that are open. This spawned a whole generation of model offspring of fine-tunes. And the Llama models come in 7 billion, 13 billion, and 70 billion parameter versions. And then on the right there, we have Mistral 7B, and now the Mixtral model, which is a mixture of experts model to rival GPT. These are from the French startup Mistral AI, the French darling startup. They are notable for not having any sort of filtering or training or safety put into their training. And I probably shouldn't say this when I'm being recorded, but unlike some other types of models, if you ask a Mistral model for how to make napalm, it will happily tell you the answer. And then from Microsoft, we have the Phi series of models, which is taking a different approach. These were trained on synthetic data, and they are small, large language models. So we're talking about models with, I think Phi 2 has only 2.7 billion parameters as opposed to hundreds of billions or even trillions of parameters. Okay, in terms of open multimodal models, these are models that work with not only language and text, but also other media like images and video and audio. The Whisper model from OpenAI is open and free to use. It is a largely multilingual speech-to-text transcription model. From Stable Diffusion and Stability AI, from Stability AI, we have Stable Diffusion, which is sort of the originator of the text-to-speech diffusion model. Interestingly, these are actually not a transformer architecture. It's a different type of model. And then from Microsoft Research and a couple other universities, we have the Lava model, which is an image and text visual question answering system. So it's like GPT-4V. You can give it images and then ask it questions about the images, and it understands things that it sees in the pictures. And people have done things like build models where you can do things like interrogate video clips using the Lava model. Okay, one last piece of background knowledge. This is it, I promise. Retrieval augmented generation, or RAG. This is where people are combining large language models and generative AI with traditional information retrieval or search approaches. So you're grounding your large language model in a data store or set of documents and giving it some sort of data that it works around to stop this problem of the models doing what is called hallucinating, where they are basically just making stuff up. Okay, so this is a big, very hot space right now, and lots of LLMs do internet searches or hit databases or documents. All right, so that's all the background materials. Now we can talk about tools. What tools do we have at our disposal to actually build things with generative AI? The basic tools of the trade, you're probably going to be working in Python 3. I am a bit biased because I'm a data scientist, and that's what I know how to write. You also want a development editor or environment, so I don't care. You can write your code in Vim or Notepad if you want, or you can use Jupyter. Boo, I know. I'm a data scientist. I'm biased. I use Jupyter. I know some developers do not like it. You probably also want, if you're doing some sort of machine learning engineering type work, you want to work with the deep learning libraries, PyTorch from Meta, TensorFlow from Google. And then now you don't even need to do that. You can get away working with Hugging Face, which is a higher level library built on top of those for working with large language models. And I'll talk about that in a bit. And then finally, you probably want to work with some model provider. So we're talking about OpenAI or Cohere or Anthropic or someone like that if you're building product with their product. Or you want to access models, foundation models, through one of the cloud providers, something like Azure, AWS, or GCP. So these are all sort of parts of the basic toolbox, standard toolkit for doing generative AI work. You could also just use ChatGPT to do generative AI. For most people, this is how they heard about AI and generative AI and all this. And lots of people use this to help them write code and just, even if they're not building Gen AI applications, help them be better at the job that they do, or even pay extra money, which I would never do, to use GPT-4 and help them do the work that they do. Right? Obviously, Microsoft, realizing this, built on the success of using ChatGPT for that type of thing with GitHub Copilot. It's no longer just sort of autocomplete on steroids for writing your code, but it's now developing into like a fully fledged AI pair programming assistant where you can chat with it inside of VS Code or other development environments and have it, help you write your code automatically. Okay, so we're not even building Gen AI applications yet. We're just using generative AI to make us better and faster developers. Microsoft expanding GitHub Copilot into Copilot proper and now integrating it into all their products and services. I do use Copilot. I like it a lot. You can just go to copilot.microsoft.com. And you can actually use GPT-4 for free through Copilot. And that is because Microsoft and OpenAI are BFFs, best friends forever. They're so friendly with each other. So that is a cool thing you can do, right? So those are all tools for helping you do development work. If you want to actually start building Gen AI things, a lot of people will just start and say, OK, I know about ChatGPT and GPT. So they'll start and say, OK, well, I'll start with OpenAI. And you can very happily go and just get your API key and put down $5 and start burning money with API requests. And this is the path to building large language model applications for a lot of developers. And there's nothing wrong with that. And I'll talk about it more in a bit. But you can also access these models and then lots of other foundation models through a cloud provider. Azure has AI Machine Learning Studio, and they have lots of foundation models. We can see here like Whisper and Llama and things like that that you can access through Azure Machine Learning Studio. There's also, of course, the other guys. You can use AWS Bedrock. They have a lot of foundation models as well as their AWS Titan model. And then Google Cloud has their model garden on Vertex AI. So those are all options for working with foundation models as well through these cloud providers. Okay, I have to remember to breathe. As a data scientist, it's funny because this is probably what you're all used to. But for me, this new future of development in AI looks a lot different than what I think about when I think of AI. And there's just a lot of calling APIs. It's APIs all the way down, right? And that's how you can build a lot of product with GenAI without necessarily getting too much into the nitty-gritty details. Okay, but there are other options and other tools, and I want to talk about those as well. Okay, so Hugging Face is kind of coming at it from the flip side, the other side, championing open source models and allowing you to do development locally and hosting model snapshots for open models, and then you can build generative AI and LLM applications using these open models. All right, and Hugging Face, the company, is kind of a weird animal, right? They basically just took libraries TensorFlow and PyTorch that do deep learning, and JAX as well, wrote a lot of Python libraries on top of that to make it easier to work with LLMs. Then they host the model snapshots on their platform through GitLFS. They host data sets through Apache Arrow and inference endpoints through Docker. And all those things kind of together make up both Hugging Face, the software, the different libraries they have, Hugging Face, kind of the company, and then Hugging Face, the platform as well that you can use to do large language model and generative AI work. Okay, and this is what that looks like if you go to their site. They have a page that has all the trending models. And you can see Google recently released their Gemma models. So those are at the top of the trending models. We also see the open Aya model from Cohere for AI. And then further down here, we've got Meta. The Meta Llama model I mentioned is very popular. And the Mixtral model from Mistral AI also remains at the top of the leaderboard here. And if you go further down, it's stability as well. Like lots of these stay at the top of the leaderboard. But if you look at like Mixtral, for example, this has been downloaded 1 million times last month. This remains a super popular open model. And it has something like 645 billion parameters or something. And if you want to download it all 65 gigabytes or whatever, and you have the hardware to run it on your machine, by all means, go ahead and see if your laptop will run it. Okay, no, I joke, but the point is that you can download these models and build applications locally without using a model service or cloud provider. Okay, other options for local development and open development. As I said, the Whisper model from OpenAI. You can actually access Whisper through OpenAI services and through their APIs. But the Whisper model itself, the weights are open, and the model code, you can just pip install OpenAI-Whisper, and you can start building applications with Whisper, and it's a completely open source model. All right, so if you want to make your startup to do multilingual speech transcription, nothing is stopping you. State-of-the-art automatic speech recognition from OpenAI, and it's open source, and you can get going. A really big development fairly recently is llama.cpp. So someone took the time and effort to originally just with Facebook's Meta's Llama model, implement that model in pure C and C++, so it runs much, much faster without the overheads of using Python and other things. And now people have extended this library, and when new models come out, you can actually run all these models locally in pure C or C++ and run them, and it's amazing what you can do now. So people have built on this, and this framework continues to be being developed. And the people at Mozilla, they took Llama CPP, they mixed it together with something I didn't know about called Cosmopolitan libc, and they came up with this file format called Llama file. So now you take one large language model, you compile it, and you get one executable per model, and that executable will run on 6 different operating systems: Windows, Linux, Mac, and then 3 different types of BSD, if anyone knows what that is. All right? So this is kind of making local models much, much more accessible and easier to use because now you just have an executable file to run a large language model. What's really exciting is that people have built on top of Llama CPP with this framework called OLLAMA, which makes it very easy to run large language models locally. It includes lots of popular models such as Llama, Mistral, Phi, and Orca from Microsoft, and a whole bunch of others. You can run a local web server with a REST API. They have Docker containers. They have it work with many, many different languages, not just Python. And very recently, they just added multimodal support, so you can actually run the Lava model locally through OLLAMA and do visual question answering with the Lava model. Okay, so really great, and I'll show this in a bit. Also exciting, they have updated very recently the chat completions API. So now if you have an application that uses GPT, you can just literally just change the URL and swap in a local model and do local development. So if you're prototyping or you want to try using a local model and see if it's different than using GPT series, it's now very, very easy to do that using OLLAMA. All right, some people just want to chat with LLMs. So there are frameworks, GUI clients for running large language models on your desktop, sort of basically like a local version of ChatGPT, if you will. So Nomic released this GPT for all. It has many, many different popular models you can download and talk with in the GUI application. And then LM Studio is actually built on top of Hugging Face. So any model that's on Hugging Face, you can actually download and run locally on your machine and chat with it in this GUI-based application, LM Studio. You do need to have good hardware to do this. My computer is not very good, and so it's very slow. But if you have a good computer and you have a GPU, you can work locally with many, many different types of LLMs. OK, one last thing. If you're doing some serious large language model application development, you want to look into frameworks like LangChain for building more complicated applications and sort of chaining together different models. There's also frameworks like Llama Index, which allow you to use these models with document stores or databases. Chainlit as well for doing more complicated applications with LLMs. And then if you're doing serious LLM applications, you probably also are working with vector stores of data. So here are some examples of vector databases, things like Weaviate, Chroma, and Pinecone. That's as much as I'm going to say about these things because I'm getting a little bit out of my depth. But if you want to do RAG, you're probably using some sort of vector store. And these are sorts of the platforms and companies that are emerging in that space. OK, so that's a lot of tools. Whew. Need a big toolbox in my garage. All right, so now that we have all these tools, we can talk about building things. I'm sorry, I'm not going to live code and build a whole startup in this talk, but I will show some sort of kind of hello world examples of using some of the different models and platforms that I have talked about, which I think is still going to be OK given the amount of time that we have. All right, so as I said, for many people, large language models and generative AI is synonymous with ChatGPT and OpenAI. So you can very happily sign up, as I said, go create your API key with OpenAI. And then basically, AI is just the same as making requests to an API and sending prompts. And then you can start doing your prompt engineering. And I feel very confident in this next statement. I am not a very good developer, but it's not too hard to get going. So like here is the hello world for doing that with GPT. It's just a few lines of code. You import OpenAI. You make a request using their library. And then I get back another nice poem about applesauce. And as I was saying, I'm not a great developer. But if you know a framework that's very simple, like Streamlit, you can even do things like make a GUI with just some lines of code. So here, you can run this locally on your machine. It's backed by the OpenAI API. I ask it to write a poem about TechTankTO. And then it writes a poem about applesauce in the TechTankTO meetup. Okay? And just so you know that I did, in fact, run this on my machine, you can see my picture up there in the top right in Chrome. So that's the amount of code to actually create this is like, maybe 30 or 40 lines of code. Okay, more local development. Here I'm doing a multimodal example. So with Hugging Face, you can run Stable Diffusion XL in 5 lines of code. They have the diffusers library. You create a text-to-image pipeline loading the Stable Diffusion XL model, and then you just put in a prompt into the pipeline, and you are done. So I ran this code literally on Google Colab and created this image of this cute dog in a fuzzy sweater. And you don't need to pay to use any AI image generators as long as you have some hardware and you are willing to download the 16.7 gigabyte snapshot of SDXL 1.0. Okay, and then if you want to build applications using Hugging Face, they have what are called Hugging Face spaces. So you don't have to be a really good front-end developer. I'm definitely not that. But if you write some simple code using a framework like Gradio, you can then deploy these different models and have them run in the browser. And then here is an example here where you can type in your prompt into this web page, click generate, that's backed by an inference endpoint, and then it will render the generated images in the browser. Okay, so very, very easy to get going with Hugging Face and start building simple web applications to demonstrate capabilities. Okay, this is my crappy Ollama demo. So first, you start Ollama by saying Ollama serve, and that will start the Ollama server. And then I'm going to go over to my other tab here, and then you can say Ollama list, and that will list all the large language models you've downloaded. I'm going to use Tiny Llama because my laptop is terrible and has CPU only. And so when you say Ollama run, it will drop you into an interactive session with the LLM. And now here I could type in my terminal, write a poem about applesauce, and then it will actually stream the text from the LLM just to your terminal. So if you want to just chat with LLMs locally, you can run Ollama and run interactive sessions with any open model and just chat with it in your browser, and it will write a poem. Okay? Also, it is running a web server, so you can hit the URL locally with curl, and then it will actually stream outputs token by token as JSON if you are building an application. Okay? So that's just like the hello world for using Ollama. I am doing this in WSL in Windows, but they just released a Windows preview build of Ollama as well. Okay, and if there are any Apple fanboys in the room, or fangirls, a few things. WhisperKit is a package someone put together where they have implemented OpenAI's Whisper model that I've mentioned already into Apple's Core ML framework, so it can run directly as part of macOS and Apple hardware. Apple just recently announced in December that they released this MLX framework, which is for doing sort of numerical and deep learning computations directly on Apple Silicon. And so people have already been using this to do things like implement large language models and have them run very, very quickly on Apple Silicon. And then there's not too much else, but according to Bloomberg, internally, Apple is testing prototypes of their own sort of co-pilot that they are going to have be part of Xcode. So there's going to be a forthcoming kind of Xcode AI assistant. And then Apple is also looking at integrating large language models, generative AI capabilities into sort of macOS proper, things like using it in Spotlight. Okay, so we are reaching the end. Hopefully you got an idea of some of the stuff you can build, and I want to leave you with some other resources where you can continue your learning. So I highly recommend, in addition to this talk, there's a really great talk. If you don't know, Andrej Karpathy is a thought leader in the AI space. He was previously the head of self-driving at Tesla, and he was at OpenAI until just very recently. But he is like one of the thought leaders in AI. And he gave this great talk, which he re-recorded, called Intro to Large Language Models. And he talks a lot sort of about LLMs from more of a technical, like developer-like perspective. And he also talks about a lot of the things that make LLMs special. So if you're new to LLMs, this is a great talk to start with. I highly recommend it. Another great resource on Reddit is the r local llama subreddit. This originally started as a subreddit to discuss doing local development with Meta's Llama model, but it now has basically evolved into just a community to talk about doing any kind of local LLM or generative AI development. And it's really funny because the top post of all time on Local Llama is actually from Andre Karpathy. It's a screenshot of Andre Karpathy's tweet where he says, "I only trust 2 LLM eval metrics, Chatbot Arena and the Local Llama comment section." So lots of people here really know what they're talking about, and this is like a great resource, or you can even just go and ask questions and people will help you. Okay? If you also are new to generative AI in general, I will tell you if you're working with OpenAI, they have a cookbook, lots and lots of different recipes for building things. Other companies have these type of cookbooks as well. Hugging Face has a cookbook they recently put together. Speaking of Hugging Face, they have lots of Transformers notebooks that give examples of how to work with their libraries and do many, many different things. Lots of great notebooks with examples of how to do things like fine-tuning or use LoRa adapters or do fancy things with images. So tons of resources out there from Hugging Face. Their GitHub is also really, really great to show lots of examples of how to do things with large language models. And then I will also recommend from Microsoft their Generative AI for Beginners course. So if you're completely new to Gen AI, there is a free course from Microsoft at that link. And this is mainly on Azure, but it is a great resource. There's videos and sort of a textbook about Gen AI, and that is completely free. And then finally, because there is so much out there and it is moving so quickly, if you want to go to the NLP from Scratch GitHub at github.com/NLP from Scratch, I have put together sort of my own awesome list. This is a living document of lots and lots of resources on natural language processing and large language models. I'm continually updating this, and then it's also organized by a table of contents, so you can actually just click and then search for whatever particular thing you're looking for, and there's lots and lots of great resources in here, okay, including other courses. All right, so that is pretty much it. That was a lot of information in a very short time. I hope you learned something interesting. If you are interested in talking more, please shoot me an email or check out nlpfromscratch.com, or feel free to connect with me on LinkedIn. All right, so that's it. Thank you very much, and if there are any questions. Thank you. And if there are any questions, I'm absolutely happy to answer them. Any questions at all?
What are some things that Meta, Google, and other companies are doing to drive down the cost of inference?
CLI time taking invisible. Are there exactly so? I think. I don't know specifically about like FANG companies doing things to drive down the cost of inference, but there are different sort of tricks that people are implementing at a lower level in terms of how these things are executed and implemented to make them more efficient. So one thing I do know is flash attention was a paper that came out, and they basically have a different way of calculating the attention mechanism that is much, much more computationally efficient. And that was one of the big things when Mistral's, I believe it was one of the big things, one of the big selling points of Mistral 7B when it came out was they used flash attention. And so that's a much more computationally efficient way. And then there's also a framework called Power Infer, which researchers came out with, and I believe it's just doing these computations in C, and there's various different tricks to doing that. So some of that is a bit beyond me. People are looking at distribution as well, about like doing distributed compute as well, right? But I think the short answer is that there's just more research that needs to be done to find sort of the computational tricks that you can do to make trade-offs between accuracy, like computing it exactly, and also saving compute, because something people don't talk about a lot is just how expensive and how much energy these different models are using. Oh, and then I cannot believe I almost forgot that. The other point is model quantization, right? So when you store the model weights on a computer, you can store them in floating point 16, and it's very precise. But through a lot of research, people have found in the past that surprisingly, you can actually just use approximate values for all the weights. And you still get fairly good results. So when you have billions and billions of parameters, you're storing billions and billions of numbers and doing billions and billions of computations. The difference between floating point 16 and integer 8 ends up being a lot. So model quantization is a way that people are saving on compute, but it's also more a way just that people can do things like take very, very large language models and then quantize them and then run them on commodity hardware. So my crappy laptop does not do well with actual large language models, but I can run integer quantized versions of models, and the outputs sometimes are a little not quite as good, but it'll still work. So there's a trade-off to be made between basically quality versus and performance versus compute cost.
Hi. So I have some idea on how neural networks work. I just had this question that what I'm assuming is that LLM, just correct me if I'm wrong, because I want to understand how LLM must be working. So now the issue with neural networks and words or language comes that one word can express many meanings, right? So if I have a folder that says happiness and a folder that says calm, there might be many common words inside, right? So that's why there are sentences that I could add on both sides to give it a reference. So now I think what I understood and what I assumed from the presentation is that we're making classes based on those connections, and maybe those connections is what the models are. Is it? Or am I understanding it incorrectly is what I just wanted to ask. Yeah, that's all. Yeah, thank you.
Yeah, certainly. Lots of good points there. So you're definitely, I would also like to understand how large language models work. So if you figure that out, please tell me. But basically you're raising a very valid point. I only know English, but many words in English mean have multiple meanings, right? So how do we take something like a word and get a computer to understand it? This is a real problem when you're doing sort of traditional natural language processing approaches, the problem of synonyms. But there's two things. For learning embeddings, you're going to have embeddings where it will have some understanding of synonyms, right? Where the word bass is a fish, but it's also bass, like a bass guitar, right? And those types of neural networks that learn those embeddings are generally better at that kind of thing. But the key thing with the transformer architecture is the notion of attention and taking into account the words around and the context of the word. And not only taking into account that context, but through training, learning which words in the context actually matter for a given word at a given position in the training data. So that's one of the reasons that state-of-the-art neural networks do so well, is because they're not just looking at each individual word. It's still, at some level, I want to be careful here, but it's still at some level just a classification task where every word has a number instead of a lookup table. But the key innovation with attention is taking into account all that context. So not just the word, but all the words around it and everything that's come before.
First of all, I just want to begin by saying I'm a complete beginner at GenAI, and just using ChatGPT has been my only mode of introduction to GenAI. So from the perspective that I might have an employer that is providing these LLM models as services or product to other companies, I'm not necessarily interacting with it as someone who's going to be tweaking them or actually teaching the models. Like you said, some of those things are just done at a very high level at FANG companies and whatnot. So as a developer, I know you said you're a data scientist, but if we step back, how else should we interact with GenAI? As from a learning perspective, we can create tools from them. That's the only thing that I can think of. But how else should we get more involved? As again, someone who's coming from my level of understanding of it. Thank you.
Yeah, great question. So the question is, as a beginner, where do we get involved? And without doing all the hard technical stuff, right? Like, I get daunted as well. Like, I can talk about these things. I'm a data scientist. I'm not a machine learning engineer, right? So it's like, hey, train a transformer from scratch. I'm like, I don't think I'm going to do that, right? And something I didn't touch on in this presentation is I don't believe there's people out there that say that, oh, all computer science has changed and there'll be a whole new paradigm where we never have to write code and we just talk to the model and say, write me a Python program. I don't believe that. Just like people are like, the paperless office, never going to happen, right? But it has changed, and something I didn't touch on in this presentation is this idea of like prompt engineering. So that's maybe a discipline you can look into. That's something people do where they're using kind of more like the APIs, and they're using large language models and looking at the outputs and evaluating them and building them in the product without necessarily doing kind of the hardcore like machine learning and systems integration type stuff. But it also kind of depends on what your goals are. Like you can work with GenAI and have it augment all kinds of different work you normally do. That's one thing. But if your goal is to get more into the AI, machine learning, and data space, I'm going to take a huge step back from this presentation and say what I say to a lot of people, and that is like, I would not put you in a 747 and teach you how to fly it before you knew how to ride your tricycle, right? So, GenAI is all the hype right now. It is amazing, but I think some people, there's still a lot of traditional ways of machine learning and even natural language processing that are in some ways like boneheadedly stupid, but they are very well suited to tasks. They are very, very good at solving well-defined problems, and you can start there and learning to apply these because, that's important work. That type of machine learning and also just analytics and all these other things are not going away. So those are kind of the two different paths I see for that.
I'll say one last question.
Oh, one more?
Yeah.
Well, I have one question. One of the premises raised by Guillaume Bourdon is that the limitation of AI progress is going to be because of energy. Do you see any potential optimizations in GPU compute that could help further advance AI? Or are we going to be limited by energy? And if you do see those optimizations, what do you think they're going to be, and what breakthroughs do you think they'll bring into AI?
Yeah, that's a great question. There's a lot in there. I will do my best to speak to the parts of that question that I feel qualified to address. So I'm not really a hardware person. I don't know anyone who works in NVIDIA, and I don't know too much about how all that works. I don't think we have reached the ceiling there yet, and they're still making money hand over fist. So I think that's going to continue. But what I will say, and what I can speak a little more in an informed way too, is two things. One is that how we got here is that OpenAI made this bet where they said, we're going to take this thing that Google made, Transformer, and then just scale it up to a ridiculous scale and throw tons of data at it and see what happens. And that bet ended up paying off, right? But now we've gotten to this point where we can do that, and many companies have done that. And I think we are finding that A, it's very hard to evaluate these things, and I may get in trouble for saying this, but B, they're all starting to become a little bit safe. So people are starting to ask questions like, do we really need 1.76 trillion parameters? And as I answered the previous question, I consider myself a pragmatist, maybe somewhat of a minimalist. So I think we're going to see with approaches like the Phi model and other series of models, not only smaller models, and maybe like the pendulum swinging back a little bit, but also saying, look, there's a space for
one model to rule them all. There's a general purpose, Swiss Army knife that can do everything. And there's a space to do the types of traditional machine learning we've done for a long time, which is we have a specific problem, we have a specific task or set of tasks. We don't need to train a 50 trillion parameter model. Let's build a reasonable model that does this thing well, and then it's part of a pipeline or what have you. So I think we're kind of in the pendulum, like reaching the top still, and I expect to see it swing back a bit, and then hopefully this will address some of the energy, environmental, and financial concerns. Thank you.
All right, guys, I'm going to cut it off just in the interest of time, since we do have a cutoff in the space. So, huge round of applause for Myles. That was